I'm in my brother's room because it was a quiet place to actually record. Um, so first off, we're gonna start with something called clean up mess. So I cleaned up this question. I realized this question didn't really explain everything. The real question was that I made up was a pull bar, a broken bar. You just pull up. I can't even do a single pull up, so don't even. Yeah, I'm weak as hell. And what did you expect from a classic nerd? Um, so I'm a fat ass too. I'm not that. I got pretty fat in college, probably. Got like I don't know how many pounds I got from college, but now I weigh like 180, and it's really whatever. I'm going on a tangent there. Yeah, my brother's room is kind of cozy. Anyway, I like this proof over here. This proof is really cool. It's just used the fact that all the tangential, because of how x and y works, must be zero. It's very trivial proof. I mean, I could just say it's not worth it for you to even look at it. It's kind of intuitive to me, to a certain extent now. In the past, it was something all amazing, but now it's not. Yeah, now you can kind of see what I was going for with that metaphorical. Oh, a lot of AP books. Oh, hmm. I know he's done. He's My brother is already going to college, so we should probably throw this out. We'll give it to someone else. Thinking about it, Eh, maybe if someone wants AP books, I'll give it to them. Um, yeah, I don't know how. I don't know who's gonna grab that. I'm just thinking in my head. Anyway, whatever. Here's a pulley question. As you can see, if you do a pulley here, the acceleration over here, you see how there's accelerating two directions. So it's actually 2A uh, of the red. And maybe I should make this color a little bit something interesting, but that's the pulley question. It's one of the interesting pulley question that everyone kind of knows about. Um, yeah, so we're doing a lot. We're going to do a lot of pulley question just because it is A, confusing, and B, interesting. And with the moment of inertia, with all those other stuff, we will be focusing a lot on it because it does give interesting insights that I never knew about, which isn't quite useful in my opinion, but it's not use. I mean, I never used it too much, so I don't really know. Um, but it's interesting in my opinion. I wish I knew the use for that. Huh. No, I think I have a use for it. Probably some kind of excavator, in case to get some kind of, yeah, I don't know, force distribution. Maybe I'll work on a little tiny like contraption. I'm trying to think if it will work for like a tiny contraption, but I'm not sure. It sounds illogical because if you go in tiny, everything breaks, and classical mechanics breaks. I don't think it'll work. It definitely will have a lot of breaking also. So whatever. I don't know. Yeah, I don't know. You can try. You can try to. I don't know if there's math for that. You probably it's just all theoretical in that part. So, anyways, as you can see, did the same thing here. I'm just gonna delete the old stuff. As you can see, this is all the screenshotting. I screenshotted up to here. The only thing left is to do R cross F, which is centroid. So no, not centroid. Center mass in this case. So just gonna do F M M G multiplied by 1.25, and you get the total moment and up to A where you cut it, and then you do the opposite over here where you cut it. So you get basically the opposite of that, and the direction of that would be, um, but since this is going that way, the direction has to go this way, right? Because the moment is this way, then it has to have an opposite moment this way. So in classical sample is a negative convention in engineering. In the physics department, I believe it's a positive convention. Just depends on actually depends on the textbook. Actually, some textbook does it the weird way. Either way, it does give you the right answer. It really doesn't matter. I'm just saying it doesn't matter, but it does matter in my opinion. But um, so yeah. Hmm. Yeah, I want to see what other books my brother has. Steve Bones, the best tutorial. Ooh, another cutie. I guess we can do the classic Popeye with this. I don't know, Popeye. I always love that. Bears. There's a lot of bears in this house. Over here, I realized I forgot to do the momentum real quick when I was in his room, so I'm just gonna really do it real quick. So it's basically R time across F, which in this case I'm using the magnitude, just say because it's magnitude and without the direction, it's just R times F times sine theta, which gives you the thing over here. Which is why I'm just gonna quickly screenshot it and put it in there. Really don't care too much about the size, but we know what the moment it needs to be over here. Real quick, I didn't really do this earlier, so let me. Should work. Yay, we got the answers to 562.5, which is completely different than what I thought I would get, but good answer nonetheless. I think it's reasonable and it's valid, so we're good. Actually, I don't like that screenshot, so we're just gonna re-screenshot it. It just didn't really fit well, so just in case I want to box it in for some reason, I might need to do that. If I remember correctly, I didn't do a lot of momentum question in the physics department, so I might not do it until I get into dynamics.